Hello, my name is Gable Fond, and it is currently 8:47 in the morning, which is probably the earliest I've woken up for anything in the last month and a half at least. So this is definitely important to me. Now, to all of my friends back in the Inspire program, or really just anybody who happens to stumble upon this video on YouTube, what I'm going to be explaining is at what angle fish do we fire any rudimentary object and achieve the greatest distance along the x-axis, or the ground. It should be that dot right there. Yes, I know that's technically an alpha, but I like the word fish better because it's so much funnier. Um, Now, for those of you who were privileged to attend the Rocket Science VSC last week, you know that we were asked to perform a series of experiments involving a foam rocket and, other various materials. Um, Foam rocket experiment, we had to construct this foam rocket and then fire it at as many angles as we had time for, just to rehash my introduction to this video I put on the Inspire website. Um, Now, most of us found that you'd get the greatest distance, or at least, judging by the responses of most of, you know, most of the people who responded, um, the greatest distance at an angle of 35 to 50 degrees, roughly, um, so 35 to 50 degrees. I do not like these answers at all, mainly because there's a 15-degree difference between 35 and 50 degrees, and I'm sure there has to be some sort of optimum. Now, there's always going to be this room for error here, and there always has to be, mainly because of air drag and some sort of lift that might be acting on the rocket as it flies through the air. However, that's not going to be, drop my pen. That's not going to be covered in this video, mainly because that's a much larger topic than, I mean, this could take 4 times the length of the video would be if I just explained to you trajectory without air drag or lift. So let's just assume we're doing this on the moon and leave that for you guys to whittle out until my next video, if there ever is one. I mean, if you like it, I'll probably do another video. Now, what I want to find first is how to describe the trajectory of this projectile, assuming that the ground is flat and, you know, there is no air drag, or that the effects of air drag on the object are negligible. Um, so let's do a couple of thought experiments. Let's say we shoot this thing, whatever the thing happens to be, let's say golf ball. Shoot the golf ball at an angle of fish equals 0. What happens? Well, if you pick something up, it's only pulled straight down. If you move it this way or that way, gravity's not going to have anything to do with it. It's just going to pull you straight down. It's not going to do anything along the x or z plane. Okay? It only has effect over the y-axis. Or in this case, it would be the y-axis. Sorry, I forgot to label these. In this case, it would be the y-axis. So I can push it this way, and gravity is not going to do anything to stop or help me with that. It only does work down, to put it that way, for those of you who have taken physics. So what we'll get is something like that. We still have the same velocity, the same constant velocity along the x-axis. Say we shoot it at a velocity of 100. 100 seconds later, it's going to be 100 meters that way. Now, this would be, say, 10,000 meters down that way. Approximately. Assuming that's a 10, Because it's accelerating that way. It's not just a constant velocity that way. Gravity is 9.8 meters per second squared. So it accelerates in that direction. You don't get any height at all in the y direction. You have a negative y right off the bat. So with an angle of 0, you get a distance of 0, because if this were in real life, you'd hit the ground an instant after you threw it, which is not desirable at all, assuming that you want to make any kind of distance with your golf ball. And once again, let's say we throw it at a fish value of fish equals 45 degrees. It's right between 0 and 90. You get an arc looking something like that. which is actually parabola. We'll go through and explain that later and how that helps us to find the optimal angle. And you'd hit somewhere in that area with, say, a velocity of 100 meters per, yeah, whatever. You get it. You get the point. Now, one more time. Think you could tell me what would happen if we shot it at an angle of 90 degrees? Fish value? Just go straight up, fall straight down, because gravity doesn't push it left to right, it only pulls it up and down. Assuming that you define up as that way for any strange reason, but we're classifying up as up in this case. If that makes any sense. So yes, it goes straight up and then falls straight down because you have no velocity in the x or y direction. Now if you notice, every time that we change the angle, whatever velocity we fired it at, 100, say it's 100 meters per second. I'll write that a bit bigger so you guys can see it. 100 meters per second. At 90 degrees, none of that velocity is shared along the x-axis. You get 100 meters per second right off the bat for the y-axis. Now, if we fire it at, say, 45 degree fish value, or the alpha value of this, then we do get some, then part of this is actually used in the x direction. Okay, it's actually a positive value in this. If it was like 145 degrees that way, it'd be a negative x value, but it's still got distance to it. Now, and notice that if we shoot it at a fish value of 0 degrees, we have all of our motion in the x direction. You know what? I'm going to show this without gravity. That's going to be a lot easier to get my point across. Say we're just on a tabletop now, and we push a marble, x and y, and we push a marble that way. Okay, marble's going that way. It goes only along the y-axis. It's not going anywhere to the left or right because you only pushed it in the y direction. Now let's say we push it this way, 45 degrees off the edge of the table. So fish value of 45 degrees. This is without gravity. It's on a table now. Before it was with gravity, but I figured that might be confusing to some of you who haven't worked with trajectories. We have fish value of 45 degrees. You're sharing that between the x and y axes. Because for every second that you move, say 1 second, this is 1 second, you've moved both up 1 and over 1 with the x and y value. Now, once again, if we shot it, say, at a fish value of 0 degrees, you'd go only along the x-axis and none along the y-axis. So in 1 second, you'd still be at y equals 0 and x equals, say, 5. Just rudimentary numbers, I know. If we were working with the same velocity, they should be, shouldn't be the numbers I was giving, but we're not. Just saying random things. Now, something that really confused me a couple of months ago, because I was trying to whittle out the trajectory of a baseball for myself. Took me a good solid 3 days to do it. Total obsession, I'm sure, but major problem was that I was assuming that y moved with x. Y equals some value of x. Which in this case, it's not true at all, because if I moved along y, x isn't going to change. If I moved along x, y isn't going to change at all. So, what they taught you in school does not apply to this at all. Instead, what they call this, apparently, I only realized this just a couple of days ago, actually, is a parametric equation. Okay. All that's saying is that x along the x and y plane is some value of t. I'm going to put tx for, let's go tz.